We are going to talk about homogeneous differential equation. Homogeneous differential equation. We already know about first order, first degree differential equation can be written in a form like fxy. Can be put into form, general form like this. So if the function on the right hand side is homogeneous, then this differential equation is known as homogeneous differential equation. Now the question is, how do we know function on the right hand side is homogeneous or not? To check that, let's take an example like this. So function fxy is equal this. So function on the right hand side, if we just put lambda x lambda y for x and y, what happens? Lambda x lambda y divided by lambda x. Now we can cancel out lambda. Now you can see that we get original function again. If we just put lambda x lambda y instead of x and y, we get back original function again. So this type of functions is called as homogeneous function. If in our differential equation, in the right hand side, if we have homogeneous function, then differential equation is homogeneous. To solve this type of homogeneous equation, we use this substitution. Y equals Vx, and we get rid of all the y terms in our equation and form new differential equation using terms v and x. So let's see an example how to do that. Let's consider this example. Now using this substitution, we can differentiate this with respect to x. So dy by dx equals v plus x times dv by dx. I applied product rule of differentiation here. Now this differential equation becomes v plus x dv by dx x y equals vx divided by x. Now if we simplify more further, v by dx, we can take out x from both terms. Now we can cancel out x. Now we end up with x times dv by dx equals 1 plus v. Here on left side also we have v, so we left with 1. Now let me write many things here. Now dv by dx is equals 1 over x. You can see that this differential equation can be solved using variable separation method, the method of separation of variable. We can use that. So let's move dx to the right hand side, dx dv, and integrate with respect to relevant variable. Now this is v ln x plus c. Now we have to write v using x and y using this substitution, because our original function, original differential equation is in terms of x and y. So v equals y over x, we can substitute it here. Now ln x plus c. So y equals x times ln x plus c. If we consider another example, you can see that this is a differential equation. We can put this is into general form, x squared y squared dx. Now dy by dx is equal minus x squared minus y squared divided by 2xy. So this is our general form of first order first degree differential equation. You can see that function on the right hand side is homogeneous. If we put lambda x lambda y for x and y, we get original function again. You can check that. So this is homogeneous differential equation. We can solve this using substitution. Y equals Vx. Now what we have to do, we have to get rid all the y terms in the differential equation and form new differential equation using terms v and x. So differentiate this expression with respect to x. So dy by dx. You can apply product rule of differentiation here. V times dx by dx is 1, x times dv by dx. Now we can simplify this further. Dy by dx equals v plus x dv by dx minus x squared y equals vx. So v squared x squared divided by 2x vx. This is 2. Now we can take out 2 from x squared from here. 1 over minus v squared x squared 2v. So x squared got cancelled out. We can simplify further. If we move v on the right hand side, now if we simplify this, we get minus 1 over v squared divided by 2v. Now you can see that our differential equation finally in the form that can be solved using separation of variable method. So move all the terms, v terms left hand side and the other terms, x terms into the right hand side. Minus I'll put right hand side. Now we can integrate with respect to relevant variable. So now you can see that the derivative of the denominator is in the numerator. So we can use some integration rules. 1 over v squared. This is ln x plus c. Rather than writing this as just c, I will write it like this, ln c. So nothing wrong here because this is a constant. If we write this like this way, we can simplify further. Now this can be written as some logarithmic rules. C over x. This is ln 1 plus v squared. Now if we consider anti-log on both sides, we get this. Now we can write v using x and y using this substitution. So v equals y over x. Therefore this is y squared over x squared c over x. If you want, you can simplify further. This is the final solution.